Good morning, dear students. I'll be taking your physics classes, as you all know. So, you know that physics, the paper is of two parts, one theoretical portion and the other one is practical, 30 marks practical examination and 70 marks theoretical question paper. The 70 mark paper is also divided into different units. The first and the second unit, that is electricity and magnetism. These are the first unit. Then the second unit is optics, and the third part is of modern physics, that is basically related to atomic structure, nuclear structure and transistors. And the last part is communication. We'll start with electrostatics. The first lesson in electrostatics is electric charges and fields. Okay. The word electrostatic means stationary. Stationary. Electro plus static. Stationary charges comes under electrostatic. So the first thing is, the first topic is electric charge. From the earliest of time, it has been found that when two particles or two objects are being rubbed together, they acquire a property of attraction. You must have seen small children playing in the class. They keep on rubbing the scale with their hair and they try to pick up the bits of paper. You can see the bits of paper are being raised up by the glass. Similarly, another example you must have seen, when we are driving car, the interior of the car that is generally made up of fiber. If you just bring your hand close to the fiber, the hair, these are being pulled up. This is all due to the charge that is being acquired. Okay. So the cause of charge is basically frictional force. When two objects are being rubbed together, the two objects acquire charge. Now the second thing is what kind of charge. There can be only two kinds of charges, positive charge and negative charge. What reason? Because there is a attractional force acting between the two kind of charges. Okay, this is very well seen in take one glass rod and rub it with, this is glass rod, rub it with silk. It will acquire a charge. This glass rod will acquire a charge. Bring another glass rod rubbed with silk, and we find that the glass rod A is being repelled by the glass rod B. What does this mean? That the two glass rods have got the same amount of charge. That is why they are repelling each other. Now, instead of the glass rod B being of glass, if we take it of ebonite and rub it with fur, bring this glass rod A close to the ebonite rod B, which has been rubbed by fur, we find that there is an attraction between the glass rod A and B. This shows that the glass rod A and B have got different kind of charges present over them. So, when two glass rods are rubbed with silk, both acquire the same kind of charge, so they repel each other. When one of the glass rod is rubbed with silk and the ebonite rod is rubbed with fur, and when they are brought closer to each other, then they are attracted. This shows that two different charges are present over the ebonite rod and the glass rod. Here we cannot say that the glass rod has got positive charge and ebonite rod has got negative charge. Here we have assumed that glass rod has got positive charge and ebonite rod has got negative charge. Is it clear? This is all assumption that the glass rod when rubbed with silk has got positive charge An ebonite rod, when rubbed with fur, is acquiring negative charge. Okay. So, what you have learned, there are two kinds of charges. One is positive charge, another one is negative charge. Now, for coming to the basic theory of charges, we come to the basic atomic model. In an atom, there are protons, neutrons and electrons, out of which protons and neutrons are situated inside the nucleus, and electrons are revolving around the nucleus in a particular orbit. Now, these electrons are basically responsible for the charges. Okay, the electrons are basically responsible for the charges, electrons which are free to move. So, negative charge is because of the electrons. Now, we will talk about electrification of a body. How a body gets charged up. When we talk about any object, a body, as you can see here, I have drawn an example here. So, these are charges that are present in a body. The total number of positive charge and a negative charge in a body is always constant. A body is always neutral. It doesn't have positive or negative charge in excess. Plus and minus becomes equal to 0. So, how do they get charged? As I have stated earlier, the electrons are only movable. These are only transferable or movable. So, if a body gets plus electron, it becomes negatively charged. So, if I transfer electrons to a neutral object, there are more number of electrons, there is surplus of electrons on the body. As a result, the body gets negatively charged. Similarly, if I take away electrons from this neutral body, then as a result, it will become positively charged. So, any object acquiring charge depends only upon two processes. One, either the availability or the addition of electrons or deficiency of electrons. If electrons are added up to an object, it becomes negatively charged. If electrons are taken away or withdrawn from an object, it becomes positively charged. So, all material can be classified into two: conductors and insulators. All those substances that allow the current to flow through them are known as conductors. And those materials that do not allow the current to flow through them are known as insulators. Examples of conductors are metals, human body, electrolyte, ionic compound. These are the examples of conductors. And examples of insulators are non-metallic substances. These are non-metallic substances. Then that is covalent compounds. Covalent compounds are also bad conductors or insulators. Then we talk about the SI unit of charge. The charge is basically, I told you, because of the electrons. So we have to find out the SI unit of charge. We know the definition of current. Electric current is equal to charge upon time. So charge is equal to current into time. Current is measured, the fundamental unit of current is ampere, time is second. So SI unit of charge is coulomb. 1 coulomb is equal to ampere into second. So 1 coulomb is equal to ampere upon second. Although now here you can understand one very important concept here. We have electric current equal to charge upon time. Current is dependent upon charge and time. So current is a fundamental unit. Charge is not a fundamental unit. Although the current is dependent upon charge, but the charge is not considered to be the fundamental unit. Okay. So therefore we are getting the unit of charge in terms of the fundamental unit ampere and second. So 1 coulomb is equal to 1 ampere second. Now charge. When you talk about the charge is on an electron is equal to 1.6 into 10 raised to power minus 19 coulomb. Minus. charge on a single electron is equal to minus 1.6 into 10 raised to power minus 19 coulomb. If an object acquires one extra electron, it becomes negatively charged, and the charge developed on that material or object is equal to minus 1.6 10 raised to power minus 19 coulomb. Or similarly, if an electron loses away one electron, then it will have the same amount of positive charge present over it. Three important properties of electric charge. Three important properties of electric charge are quantization of charge. This is the most important property, quantization of charge. Second property is conservation of electric charge. And the third property is invariance property of charge. Let us discuss the first property, quantization of charge. What do you mean by quantization of charge? This is Q equal to plus minus NE. That is, the total charge is the integral multiple of the charge present over the electron. This is very important, often asked in the examination in 1 mark question in section A. Q equal to plus minus NE. Plus minus means it can be positive charge, it can be negative charge, but the whole charge is integral multiple over of the charge present over the electron. To make it simple, N can have 1, 2, 3, 4 value. What does this mean? N cannot be fractional. Charge will be either 1 time 1 into 1.6 into 10 raised to power minus 19 coulomb, or it can be 2 into 1.6 into 10 raised to power minus 19 coulomb, and so on. All these values, E stands for the charge present over the electron, and N is 1, 2, 3, 4, and so on. So the total charge will be N times the charge present over the electron. This is known as quantization of charge. A very important concept. Means the charges cannot be in fractional value of the charge present over the electron. Is it clear? The charge cannot be the fractional value of the charge present over the electron. This is a very important concept. So it can be charges, Q can be twice E, thrice E, 5 times E, 100 times E, any time. But it should always be an integral multiple of the charge present over the electron. Now we start with the second property of the charge, conservation of electric charge. Now as I told you, every object is neutral. A glass rod when rubbed with silk. What happens when a glass rod is rubbed with silk? There are electrons that are transferred from the glass rod to the silk. Let us take an example. Suppose 10 electrons have been transferred from the glass rod to the silk. Then the glass rod will have the charge equal to plus 10. And the silk will have the charge equal to minus 10. If they are rubbed together, again both will get neutral. So, same, if an object A when rubbed, it acquires plus 10 charge, 10 charge plus 10, then the B will acquire minus 10 charge. Okay, so this is one example. Total charge before and after is conserved. Two neutral bodies will rub together. One will get positive charge, the other one will get negative charge, and both will get equal and opposite charges. Then there is another example of conservation of electric charge in nuclear physics. We have a pair production where a gamma photon ray strikes the nucleus in nuclear electric field. A positron and an electron are produced out. These two particles, this is a particle which is written as E, it is known as positron. Its mass is negligible, has charge equivalent to plus positive 1.6 into 10 raised to minus 19 coulomb, and an electron. Together, the charge of both the particles is equal to 0. This is known as pair production in nuclear physics. The third property of the charge is invariance property of charge. It means that when the charge is in motion, that is kinetic charge, and if the charge is stationary charge, the value of the charge does not change. Is it clear? When the charge is moving with a certain velocity and when it is stationary, the numerical value of the charge does not change. It remains the same. So this is known as invariance property.